The Earth was formed about 4.5 billion years ago through a process called accretion. Here's a simplified explanation of how it happened. 1. The solar nebula. Around 4.6 billion years ago, the solar system began as a giant rotating cloud of gas and dust known as the solar nebula. This nebula was composed primarily of hydrogen and helium, with trace amounts of heavier elements like carbon, oxygen, silicon, and iron. The nebula was vast and cold, but over time, it started to collapse under its own gravity. 2. Collapse and formation of the Sun. As the solar nebula collapsed, most of the material concentrated in the center, forming a hot, dense protostar, what would eventually become the Sun. The remaining material continued to orbit around this protostar, forming a flattened, rotating disk called the protoplanetary disk. 3. Accretion of solid particles. Within the protoplanetary disk, temperatures were higher near the center and cooler further out. In the cooler regions of the disk, small solid particles made of rock and metal began to stick together through a process called accretion. Initially, these particles were tiny, ranging from micrometers to centimeters in size, but over time, they collided and stuck together, forming larger and larger bodies. 4. Formation of planetesimals. As the process of accretion continued, these clumps grew into planetesimals, which were about 1 kilometer to several kilometers in diameter. These planetesimals were the building blocks of planets. Gravitational interactions between planetesimals caused them to collide and merge, leading to the formation of larger bodies, known as protoplanets. 5. Growth of the protoplanet Earth. In the region of the protoplanetary disk where Earth was forming, the building blocks were primarily composed of silicate minerals and metals. As planetesimals continued to collide and merge, the protoplanet that would become Earth grew larger. As Earth's mass increased, its gravitational pull became stronger, allowing it to attract more material and grow faster. 6. Differentiation and core formation. As the early Earth grew, it became increasingly heated due to the energy from impacts, radioactive decay, and gravitational compression. When the temperature was high enough, the interior of Earth began to partially melt. During this process, called differentiation, denser materials such as iron and nickel sank toward the center, forming Earth's core. Lighter materials such as silicate minerals rose to the surface, forming the mantle and crust. 7. Giant impact hypothesis, formation of the Moon. About 4.5 billion years ago, when Earth was still young, it is believed that a Mars-sized body, often referred to as Theia, collided with Earth. This catastrophic impact ejected a significant amount of debris into space. Over time, the debris from this impact coalesced to form the Moon. This event is known as the giant impact hypothesis and is supported by the similarity in composition between Earth's mantle and the Moon. 8. Late heavy bombardment. After Earth and the other planets had formed, the solar system experienced a period known as the late heavy bombardment, which occurred about 4 billion years ago. During this time, Earth was bombarded by a large number of asteroids and comets. These impacts delivered additional material to Earth and may have played a role in delivering water and organic compounds, which are essential for life. 9. Cooling and formation of the atmosphere and oceans. As Earth continued to cool, volcanic activity released gases trapped inside the planet. This process, known as outgassing, contributed to the formation of Earth's early atmosphere, which was composed mainly of water vapor, carbon dioxide, methane, ammonia, and other gases. As the planet cooled further, water vapor in the atmosphere condensed to form clouds, and eventually rain began to fall. This rainfall accumulated on Earth's surface, filling basins and forming the first oceans. 10. Development of a stable crust and early life. Over millions of years, Earth's surface continued to cool, leading to the solidification of the crust. Plate tectonics, driven by the heat from the interior, began to shape the planet's surface, forming continents and ocean basins. By about 3.8 billion years ago, the first signs of life appeared in the oceans. These early life forms were simple, single-celled organisms, and their development marked the beginning of the long and complex history of life on Earth. 11. Ongoing evolution of Earth. Since its formation, Earth has undergone continuous change. Plate tectonics has reshaped the surface, causing the formation and breakup of continents. Volcanic activity, erosion, and other geological processes have constantly modified the landscape. The atmosphere has also evolved, with the development of an oxygen-rich atmosphere around 2.4 billion years ago, largely due to the photosynthetic activity of early life forms. This oxygenation event was crucial for the development of more complex life forms. Today, Earth is a dynamic planet with a rich and complex history that has been shaped by a combination of cosmic, geological, and biological processes. Its unique conditions have made it the only known planet to support life.